All right, the final part on our notes, well, maybe almost the final part, is non-differentiability. So we're talking about when something isn't differentiable. So basically we're saying, when is there not a tangent, when is there not a tangent line? When is there not, when can we not find the derivative of a function? So there's a couple different places. Here's some pictures to help you visualize that. First, we have a hole. Where there's a hole, I can't find the derivative. I mean, and that makes sense that the function doesn't exist there, so it's not actually changing at that very point right there. So there, it's not differentiable where there's a hole. Where there's a jump, it's not differentiable, again, because it doesn't exist at that point, okay? Where there's a vertical asymptote, it's not differentiable. So it's, anytime it's not continuous, it's not differentiable, okay? So we can only differentiate or find the derivative of continuous functions, or at least the continuous intervals of a function. So we can't differentiate in functions at points of discontinuity, okay? So these three are discontinuous functions, therefore they have places where they're not differentiable, meaning I cannot find their derivative. The other places that are not differentiable are in continuous functions, but we still can't find their derivative. Because like right here, this is a sharp turn, okay? It's like the absolute value function or any of those other ones that has a sharp turn, right? So at this point, it's like, it's changing, it's negative, and all of a sudden, bam, it's positive, okay? So the at that sharp turn right there, it's not differentiable. We can't find the slope of that tangent line. And so anytime you're trying to figure out if you can differentiate at a point, try to figure out if it's a really sharp turn, right? So figure out if it's going like really, really negative and then quickly starts going positive, or if it's going like at a slope of 2 and -2, and then all of a sudden it's going at a slope of -1. That would be a sharp turn that you could not differentiate. Okay, and then the other place we can't is where there's a vertical tangent line. So basically, if you look at this picture, when the tangent line is going to be up and down, it's going to be a vertical line, we can't differentiate that because what's the slope of that line? Well, think back to slope, dude. It's undefined. Okay, so it's undefined. So the slope of that tangent line is undefined. We can't actually differentiate at that point. So anytime a function has this kind of weird little thing right there where the tangent line is going to be vertical, we can't differentiate. So if a function is not continuous, it's not differentiable. Basically, those first ones we saw. It can be continuous and still not differentiable. That's totally possible, like we saw. So let's find where these are not differentiable and give a reason why they're not. Okay, so this one, we just have to picture the graph. We just have to picture the graph of this, and it's a V. It's that V I was just talking about, okay? And so at this sharp turn right here, it's not differentiable because it's a sharp turn. So it's not differentiable at x equals 0 because there's a sharp turn. Okay, let's look at this one. Now let's first figure out if it's continuous or not, because if it's not continuous, that's the obvious answer that it's not differentiable where it's not continuous. So let's look. Okay, so when x equals 0, this one equals 0, and this one equals 0, so it is continuous. So this is like, this right here. It's a parabola, okay, and then it goes into the line, all right? So the question is it differentiable at that point? Well, is that a sharp turn? Well, let's figure out. Okay, well, the derivative at this point is 2x, right? So f prime of x is 2x. So that means the slope of the tangent line at 0 is 0. Well, and the derivative of the other half, this half is just 1, meaning the slope of the tangent line at this point is 1, Okay, so that is a sharp turn. So we're going from a 0 slope to a 1 slope really quickly, like instantaneously at 0 we go from a 0 slope to a 1 slope. That's a sharp turn. So this is not differentiable at x equals 0 because of a sharp turn as well. Okay. This one, again, let's check to see if it's continuous, because that's the easy one. If it is continuous, then we have to decide if there's a sharp turn at that spot. Well, at x equals 0, this equals 0. At x equals 0, this equals 1. So there's a jump. So this is not differentiable at x equals 0 because of the jump discontinuity. Okay, let's take a look at this one. Where is this function not continuous? Well, we just learned earlier in this unit, it's not continuous where there are holes, or where there are vertical asymptotes, or where there are jumps. Well, it's not a piecewise, so there's no jumps, but it could have some holes or some vertical asymptotes. Well, we know that it's not continuous at x equals 0, and it's not continuous at x equals 1 because of these denominators. And then if we cancel these two out, we know that x equals 0 is a hole, and x equals 1 is a vertical asymptote. So we know that this one's not continuous at those 2 points, so we would say it's non-differentiable at these points because it's not continuous. So again, it has to be continuous. If it's not continuous, it's not differentiable. And if it is continuous, there's still a few points where there's still a few conditions where it might not be differentiable. Okay, so let's look at this one. Is this one differentiable? So this is, let's see, oh yeah, so this is really f of x equals x to the 1/3, okay? So what does this look like on a graph? We could think about that, but you know what we could also think about is, let's look at the derivative. F prime of x of this one would be 1/3 x to the negative 2/3, okay? Now f prime, so this is really 1 times 3 times the cube root of x squared. So that's what this looks like. And at x equals 0, we have a 0 in the denominator here, so that's where our derivative is undefined. Okay, so when we first look at this, we're like, I don't know if there's like this spot in the graph that goes like this or not, right? So we find the derivative, and then we say, okay, is the derivative ever equal to, is the derivative ever undefined? And so we look at this and we know, we've seen this function before, and we've seen this and said, hey, where is this function undefined? Where is the domain of this function? Well, we know that this function is not defined where x equals 0. Because if x equals 0, we get a 0 in the denominator, right? So this, if I put in x equals 0, I get this out, right? So there is a, we'll say that the vertical tangent at x equals 0. So this one is not differentiable at x equals 0 because of that vertical tangent. Okay, one more video on rate of change.